Okay, welcome back. I'm going to go through these sorting algorithms: bubble sort, insertion sort, and selection sort. All right. So this code that I've got right here is posted for you guys. It's the source code for these, and I'm just going to do a hand execution on these. So what do we got? We got bubble sort. I've got a hard-coded array. This kind of input will work for most of the programs in this course. You can consider this to be the input, and it's just hard-coded, so you don't have to re-enter it when you run the program. Okay, I've got a couple of prototypes here: print array, swap, and bubble sort. There's main. It prints the array, then it goes into this bubble sort routine down here, and then it prints the array again. And bubble sort has two nested loops and a comparison and then a swap. And here's the swap code. It just uses a temporary variable to swap two elements around. And there's the print array code. So let's go through bubble sort here. So the idea with bubble sort is that you compare elements in pairs, and you take the smaller one and you put it on the well, in this case it'll be the left, but you put it on the advancing side of the iterator. Now the iterator is going to go this way in this example, so we'll compare and we'll make sure the smaller one is on the left. So here's my array: 24, 13, 26, 1, 2, 27, 38, 15, 10, and then we've got the outer loop is really, you can think of it as just a counter. So I don't even know if we even really need to put it anywhere, but let's, it's 0. And then j starts at size -1, which is the last guy. So j is here, and then j is going to run until it gets to 0, so it's going to run that way. And this comparison is saying if a sub j is less than a sub j -1, in other words, if this one is less than this one, which it is in this case, the 10 is less than 15, then swap them. So these two get swapped. So now we've got 10 and 15, and then j, the inner loop iterates, so j moves down. Now we're comparing the 38 and the 10, and the 10 is smaller, so we swap them. So the 10 goes here and the 38 goes here, and the j moves down. Now we're comparing the 27 and the 10. The 10 is smaller, so we swap them. The 10 goes here and the 27 goes here, and the j moves down. Now we're comparing the 2 and the 10. Now the 2 is already smaller, so no swapping. But j still moves down. So now we're comparing the 1 and the 2. 1 is smaller, so we don't have to swap them, but j moves down. And now we're comparing the 26 and the 1. 1 is smaller, so we swap them, and the j moves down. Now we're comparing the 13 and the 1. 1 is smaller, so we swap them, and the j moves down. Now we're comparing the 1 and the 24, and 1 is smaller, so we swap them, and j moves down, which terminates the inner loop. This guy increments, I increments, j resets, and we start the whole thing over again, which I'm not going to do, but you can see what happened is that it grabbed the 10, it moved the 10 up a little bit, then it grabbed the 1, and it moved the 1 all the way to the end. So the 1 floated to the top. And that was the first pass of the outer loop. Okay, if that happens, when the outer loop goes again and this whole process repeats, it'll move the 15 up a little bit, then it'll grab the 2 and move it the rest of the way. So I want you to execute this fully and show every swap for the entire operation, but you can make it a little bit easier by using some code to do that. So there's another video I posted on showing you how to do that. But in the end, you want to generate a hand execution that anybody can understand without having to look at code, okay? Because we're studying the algorithm, right? Which exists independently of its implementation. You can sort of think of it that way. All right. That was bubble sort. Let's look at the next guy, which is insertion sort. Okay, the idea with insertion sort is we have a unsorted part of the list, which in this case will be on the right, and then we have the sorted part of the list. And what we're going to do is we're going to pick items off of the unsorted part and put them into the proper location in the sorted part. And that might involve moving some items down in the sorted part. Okay, so here's our array. 24, 13, 26, 1, 2, 27, 38, 15, and 10. Okay, all of this is the same as before, except we're calling isort. We've got an outer loop that executes 9 times, and once again, you can sort of think of this as a counter, but not exactly. So, okay, this one's it's a little bit hard to get it going because there's some weird logic in here. But first, I is 0, it's here, and j is I, so j is here, and then there's this temp variable, which just stores the 24. Okay, so temp equals a sub I, so it stores the 24. Then this doesn't iterate, it doesn't execute the first time because j is 0. So this conditional is false, so it just, the inner loop doesn't execute, and then a sub j equals temp just copies the 24 back to where it was. So the first loop is kind of a not too much happens, nothing happens, so just a weirdness of the implementation detail is what we say. So I was 0, now I is an increment to 1, so I is here now, and then j is I, so j is here. We store temp. Temp is 13 now. So at this point, you can sort of think of this as the sorted part of the list. This is the sorted part, and this is the unsorted part. So now what happens? So j is not 0, so this might execute. So while a sub j minus 1, it's looking at this one, is less than temp, then a sub j equals a sub j minus 1. It's actually while a sub j minus 1 is greater than temp, which it is, right? While a sub j minus 1 is greater than temp, then you basically going to copy the 24 over here, and then j scoots down, which terminates the loop, and then the very last thing you do is copy the 13 here. So that was that. So now we've got 13, 24, 26, 1, 2, 27, 38, 15, and 10. And I moves down. This becomes a 2. I moves down. J matches it, and so you could sort of think of the sorted part of the list, which here I drew it here. I could have drawn it here. Let's say this is the sorted part. So we have this sorted stuff, and we're picking the next item in this unsorted group. We're just running down, picking the next one, and then putting them in the correct location in the sorted part. So we're inserting numbers into the correct location in the sorted part. All right, and to do that, we might have to scoot some guys down. So we're still over here. So temp is now temp is now 26, and then we're going to look at the guy before and see if it's greater than 26, which it isn't. So we scoot j down, and we look at this guy. Is it greater than 26? It's not. So we scoot j down again, and it terminates. So now these guys are. This guy's done. This iterates to 3. So it doesn't seem like it's doing much, but it should do something now. So now this will be the sorted part. I scoots down to here, j scoots down to here, we store the 1. And that was this outer for loop incrementing, and then the j resetting, and the temp storing the ace of I, and then we're going to look at this guy, ace of j minus 1. Is it greater than temp? And it is, which means we copy j minus 1 to j. So we're copying 26 here. We scoot the j down. And we're looking at the guy before j. Is it bigger than this? And it is. So we copy this guy to here and scoot the j down. Then we're looking at this guy. Is it bigger than this? And it is. So we copy the 13 to here and scoot the j down. That makes this false. Okay, loop terminates. Last thing we do is copy temp to this location. So what we've got is 1, 13, 24, and 26. Do you see what happened? We picked another item in the list and we scooted everybody down to make room for that new item in the correct location. Right? We scooted everybody out of the way so we could put the 1 in there. Okay, so we'll do one more time. So now we're going to sort this. That is, we're going to take the 2 and put him here by scooting these guys down. Okay, so 27, 38, 15, and 10. So I becomes here and j becomes here, and we store in temp, we store the 2. Okay? So we're going to look at these guys, and as long as they're bigger than 2, we're going to scoot them down. And we keep doing that and as long as they're bigger than 2, and then when we stop, we put the 2 there, where we're at. Okay, so I'll say that at a higher level, what we're doing is we're picking items off of the end of the unsorted part and inserting them into the proper location in the sorted part. That's why it's called insertion sort. So we're going to look at this here. We're going to let's see what's going on here. Yeah, it's easy to get confused here. So while ace of j minus 1 is greater than temp, so this is ace of j minus 1 because there's j. It's greater than temp. So we copy. We make ace of j be ace of j minus 1. In other words, we could move the 26 up here and then scoot the j down, and then check again. This guy's still bigger than 2, so we copy the 24 here and scoot the j down. And we look one before the, you look at aj minus 1, one before the j, it's bigger than 2, so we copy it over here and scoot the j down. Then we're looking over here, and this guy's not bigger than 2. That terminates the loop, the inner loop. Then the last thing we do is copy temp to here, put the 2 there. Okay, so we got 1, 2, 13, 24, 26. Those guys are sorted. We'll add one more, and I don't think I'll do it, but the I will go here and the j will go here. So it looks to me like nothing is going to move because we're going to store the 27 in temp, and then we're not going to find anything bigger than 27, so nothing's going to move. And that same thing will happen with 38. Nothing will move, but when we get to 15, we'll move these guys over that away and then put the 15 in there. Okay, that's insertion sort. So once again, I want you guys to execute the entire thing until showing every step until it's sorted, but don't expect you to totally do it by hand. Watch the other video on how to do this, but I want you to generate code from the machine and then take that code and annotate it. That is, mark it up with pens or with highlighters. You could do that in Excel. You could do it manually. And then assemble all that into a nice PDF document. Okay, one more algorithm. We got selection sort. So here, the keyword is select. We're pulling items from the unsorted list and putting them into the sorted list. So what we're more specifically, we're scanning through unsorted items, finding the biggest item and putting it in the next position in the list. So we'll go through and we'll find the biggest item, put it at the end. Then we'll do that again. We'll find the next biggest item, select it, put it next to the last guy we just did. Then we'll scan again and find the next biggest item and stick them in there. So we repeatedly find the next biggest item in the list. So here we go, 24, 13, 26, 1, 2, 27, 38, 15, 10. And the code's a little mess here, but so I starts at the end and runs this way, while I is greater than or equal to 0 goes that way, it goes to the left. Then j equals 0, so j starts here and m starts here. Okay, you can think of m as the max. So the first thing we're going to do is find the biggest guy and put it at the end. So we want to find the 38, put it at the end. Then we're going to scan it again, and the next biggest item will be the 27. And we'll put him next to the 38. So we're selecting the next biggest item. Then we'll select the 26 and put it at next. Okay, so let's do that with codely, detail. So while j is greater than, well, j is less than or equal to I. So j is going to go all the way here to I, right? Okay, if a sub j is greater than a sub n, then m equals j. In other words, if you find something bigger than what you're at, that becomes a new m. So j is going to go over here, and 26 is bigger than 24, so that becomes a new m. Then j will continue, and I'm not really showing, j is going to go this way, I'll just show it, and it'll find this, and m will be that. Then it'll find this one, which is bigger than m, so that'll be the new m. Then j will find this guy, and that'll be the new m, and that's the biggest m. And then j's done, the inner loop's done, then we swap I and m. We swap these two guys. So the 10 goes here, 15 stays there, and the 38. And 27, 2, 1, 26, 13, 24. So you can think of this here as the sorted part of the list. And the rest of it's the unsorted list. Okay, so then we're just going to scan for the next biggest item and select it and put it in at the end of the sorted array. So I goes to here, I decrements on the outer loop, I minus minus on the outer while loop. Then j and m start here at 0. And then j scans all the way across looking for a bigger m. So it finds this 26, m comes down here. It finds this 27, m comes down here, and it stops. Or m stops. J scans all the way across. M gets updated here, m gets updated here, and j finishes. Then we swap this with I, the last position. Okay, we swap I and m. So the 15 and the 27 get swapped. You could think of this as the sorted part of the list now. 10 stays there, the 2, the 1, the 26, the 13, the 24. Okay, so we have the sorted list is sort of growing over here on this side. Okay, I decrements on the outer loop, j and m reset, I scans and finds this bigger m, and then that's it, and j will finish, having found this bigger location for m. Then it'll swap these two guys, so the 10 goes down here and the 26 goes down here. These are now the sorted guys, and the rest stays. Okay, I scoots down, j and m reset, j scans, does not find anything bigger than 24. So then m and I swap. 15 comes down here, the 24 comes down here. This is now the sorted stuff. All right, 1, 2, 10, and 13. Okay. I iterates on the outer loop, scoots down, j and m reset. J scans over here, doesn't find anything bigger. So then it swaps these two dudes. So 12, 13, 10. So 12 and 15 swapped. And these are now the sorted guys. I decrements in the outer loop, J&M reset. Doesn't find anything bigger, it goes down. A couple more of those dudes and this thing's swapped, or all sorted. Looks like a good algorithm. So once again, I want you to generate a nice hand execution. Go watch the other video, and that's about it. All right, I hope that was helpful for you. You can study what I've just done here. I think I've posted something similar to this as well. Some documents. You can study this code, and there might be other resources you can find on the web. I think there's a little bit in the notes, my notes about this, but mainly this video you're watching now, and then the second video on how to do homework 0 should be enough to get this thing done. All right, thanks. See you next time.